All right. Hello again, everyone. Today we're going to talk about something called cross multiplying, but more specifically, these are equations where you have a fraction is literally equivalent to another fraction. So when you see, okay, I have a fraction, it equals another fraction, you can use this thing called cross multiplying or some other methods that we're going to talk about today. So when I see this, okay, I've gotten a fraction equals another fraction. These are equivalent fractions. This fraction equals this fraction. So the first thing I can say to myself is, okay, well, like how does this fraction become this fraction? What am I multiplying by or dividing by? And if we look at this, we do a little bit of thinking, we can see, oh, wait a minute, well, 5 times 7 would give me 35. So whatever I do to my denominator, I have to do the same thing to my numerator. So 2 times 7 would be, and we get, okay, x must be 14. 2 over 5 is the same as 14 over 35. And if you even wanted to check this, well, you could say, okay, well, 2 divided by 5, if we use a calculator, I think that would end up being 0.4. And over here, if we did 14 divided by 35, that would also equal, I believe, 0.4. So now we know, okay, x equals 14. Same thing over here. I look at my equation. Okay, I have this is a fraction equals another fraction. So we just say to ourselves, well, how does this fraction become this fraction over here? And okay, with some, what's going on? How do we figure this out? And well, wait a minute. If I do 28 divided by 4, well, that would end up giving me 7 over here. And whatever I do to my numerator, I have to do the same thing to my denominator. So I should take this and divide it by 4. And 8 divided by 4 means, well, over here, x should equal 2. And so 7 over 2 is the same thing as 28 over 8. And that makes sense. If I reduce this fraction, it would become 7 halves. So at this point, if you're okay with that, that is great. But I'm going to show a new method for how we can solve these things using something called cross multiplying. So let's go back over here and let's pretend that you were looking at these problems and you just could not figure out how to solve them. You couldn't make the fractions equal to each other. You couldn't see, like, how would I make this fraction become this fraction? We can use some ideas from solving equations. So we can use this idea. It's called cross multiplying. But what we're going to do is we're going to look at this equation and say, you know what? I don't really want to work with fractions. I'm going to change this so that I'm not going to have an equation involving fractions. So to do that, I can say to myself, okay, well, on this side, if I want to get rid of this divide by 5, well, I'm going to kind of move it or do the opposite. Just like when we're solving an equation, the opposite of dividing by 5 is I can multiply by 5. So then on this side, I'd be just left with a 2. And at the same time, well, you know what? Instead of dividing by 35 on this side, let's take this 35 and we're going to move it. Similar idea. We're going to take this, we're going to move it to the other side of the equation so that I'm no longer dividing by 35. I'm going to multiply by 35, and this will get rid of our fractions. So let me just fix that a bit, give it some more space. So now that I've moved this, I would have, well, dividing by 35, the opposite is we're going to multiply by 35. And taking this over here, I now have a 5. I'm going to multiply with the 5 and the x. So 2 times 35 is the same as 5 times x. And the nice thing about this is now I still have an equation to solve, but I've gotten rid of the fraction part of things. There's no more fractions to deal with, which might make this a little bit nicer to figure out. So on this side, 2 times 35 would give me 70. I still have 5 times x. And now my final step to solve this equation, 5 times something equals 70. Well, that means I have to do the opposite of multiplying by 5 is we will divide by 5. And 5 goes into 70 14 times. Actually, you know what? Let's just keep this consistent. I should bring the x down here. So 70 divided by 5 equals x. And then we would have 14 is equal to x. So we get the same answer either way. And maybe this is a little bit more steps, but this will work every time. You can use this thing called cross multiplying. So let's try this next example with that same idea. Pretend we couldn't figure out, okay, now we know we can divide these by 4. But let's just pretend we could not figure that out. we can use this cross multiplying idea and say, well, let's just rearrange this so I'm not dealing with fractions anymore. So let's take this. The opposite of dividing by x is I can kind of move that to the other side of the equation, and I'll instead be multiplying by x. And over here, the opposite of dividing by 8 is the same thing. I can take this, I can move it to the other side of the equation, so I'll be multiplying by 8. And when I do these steps, 8 moves over here, so I'll have 7 times 8 is equal to multiplying by the x on this side, 28 times x. And then 7 times 8 would give us 56 is equal to 28 times x. So 28 times something equals 56. Well, to solve this last step, I'm now going to divide by the 28 again. Equals x. So 2 is equal to x. So there's lots of different methods and ways you can solve these. So if you have a method that works, if you have a way that you can solve this and you're getting the correct answer for x over here and you're getting the correct answer for x over here, then you can use your methods. They're working. But if you ever get stuck, this is a method that will work every time, no matter what, as long as you have a fraction equals another fraction. So it needs to be a fraction is equal to another fraction, and then this can work every time. Hopefully that made sense, and you're going to see some more examples in the following videos. So these are going to get a little bit more complicated, and as they do, we can keep using our methods, and we'll solve some pretty complicated stuff by the end of this.